For the past year, there's been an uncomfortable trend in AI. The gap between open source models and closed source frontier models is getting wider, not smaller. The big labs OpenAI, Google, Anthropic pulling further and further ahead. Until today, DeepSeek version 3.2 dropped, gold medals at the IMO, gold at the IOI, Codeforce's rating of 2701, beating GPT-5's 2537. This is the moment the narrative changed. Open source AI just caught up to the frontier. I'm a strategic consultant specializing in AI and digital transformation. If you're trying to figure out what this means for your business or how to implement these models, reach out via the email in the description. Now, let me walk you through exactly how they pull this off. The DeepSeek team asked, why can't open source models keep up? They found 3 specific problems nobody else was solving. Problem 1. The architecture itself. Traditional attention mechanisms fall apart with long contexts. Not slow, exponentially expensive. That limits deployment costs, training efficiency, everything. Problem 2. Not enough compute in post-training. Pre-training teaches general knowledge. Post-training teaches reasoning. Open source models weren't investing enough here. Problem 3. AI agents. Open source models couldn't use tools reliably. They couldn't follow simple instructions, couldn't execute multiple step tasks. DeepSeek resolved all 3 systematically. Breakthrough number 1. DeepSeek Sparse Attention. Traditional transformer models have quadratic attention complexity. Every word in your input pays attention to every other word. Double your input length and your computational cost quadruples. See this, O of L squared? This gets expensive fast. Think about a stadium with 100,000 people and everyone having a one-on-one conversation with everyone else. That is impossible to scale. DeepSeek built DeepSeek Sparse Attention, DSA. It consists of 2 parts. First, a lightning indexer, fast and efficient. It figures out which tokens actually matter for each query. The key idea is instead of paying attention to everything, be smart about what matters. Second, fine-grained token selection. Once the indexer identifies relevant tokens, it computes attention only for those. It ignores everything else. The result? Complexity drops from O of L squared to O of LK, where K is significantly smaller than L. So, what does this mean in practice? Processing 128K tokens, about 100 pages of text, the older version of DeepSeek, version 3.1, would cost 70 cents per million tokens. The newer version with DSA costs only $0.25 per million tokens, a 64% cost reduction with the same performance. Watch what happens at longer context. The old model's output costs explode. DeepSeek V3.2, it's flat. For companies processing billions of tokens daily, this is millions in annual savings. The clever part? They didn't build this from scratch. They took their existing model and used continued learning to add this capability. 1,000 steps to warm up the indexer, 15,000 steps to adapt the full model to sparse attention. In total, it was less than 950 billion tokens. Breakthrough number 2. Scaling reinforcement learning. They spent more than 10% of their pre-training compute budget on post-training. Most labs don't do this. Post-training is usually a quick fine-tuning setup at the end. Make it helpful, make it safe, and done. DeepSeek asks, what if we spent nearly as much compute making it smarter as giving it knowledge? They use GRPO, Group Relative Policy Optimization. What makes it work at scale are 5 specific techniques they developed. 1. Fix the mathematical bias in KL divergence estimation was causing training instability. 2. Better handling of off-policy data. When training on data doesn't match your current model, things get unstable. They added masking. 3 and 4. Handling their mixture of experts architecture and sampling strategies, making sure training is consistent with deployment. 5. Adaptive penalties for different domains. Math problems need different training dynamics than coding problems. Their training strategy is clever. They didn't train one big model. First, they created specialized model for each domain, a math specialist, coding specialist, reasoning specialist, agent specialist, each trained with massive RL compute in its domain. Then they distilled all that specialized knowledge into one general purpose model. What did this get them? They essentially tied GPT-5 in AIME 2025. They beat GPT-5 in HMMT. Their Codeforce's rating is 2386, competitive programming at near expert level. They also made DeepSeek V3.2 special. Trained with less restriction on thinking length, it can use more tokens to reason through problems. This is a general purpose model, just raw reasoning ability. Breakthrough 3. Large-scale agentic task synthesis. First, they solved a practical problem. Thinking models like DeepSeek R1 reason through problems step by step, which is great for complex tasks. But in agent scenarios with multiple tool calls, throwing away reasoning after every tool interaction is wasteful. Their solution? Keep reasoning in context while working with tools. Only discard when the user sends a new message. Let's understand that with an example. If you're solving a math problem that needs a calculator 3 times, you don't forget your whole approach between users. The big innovation: a massive pipeline to synthesize training data for agents. Here's one synthesized task. The trip planning problem. Plan a 3-day trip from Hangzhou, can't repeat cities, hotels, or restaurants. All recommendations must be in the right city. The twist? Budget constraints change based on hotel tier. A luxury hotel over 800 yuan. Restaurant spending under 350 yuan. Both restaurants need 4-star ratings. Attraction ticket under 120 yuan. Mid-tier hotel, different constraints. Budget hotel, different again. The model has 15 tools. Getting city info, checking weather, finding restaurants, looking up hotels, getting attraction details. It must reason through this constraint satisfaction problem using only these tools. The genius? Hard to solve, easy to verify. Verification function just checks if constraints are satisfied. They created 1,827 unique environments, each with its own tools, database, and verification logic. The payoff? MCP Universe 46% success rate. Close to frontier models. Tool decathlon. It got 35.2% and beat GPT-5, which only got 29%. Terminal Bench 2.0, it got a 46.4% accuracy. They tested synthetic tasks against frontier models. So, why does this matter? First, it proves open source AI can compete with frontier labs. The narrative that only billion-dollar companies can build cutting-edge AI just got challenged. Second, architectural innovation matters more than raw compute. DSA's 64% cost reduction is a paradigm shift for anyone deploying AI at scale. Third, agent capabilities show a path to practical enterprise AI. These aren't toy benchmarks, real tool use scenarios with business value. The DeepSeek team is upfront about limitations. General world knowledge lags behind models with more pre-training compute. They spent less on pre-training. Token efficiency is lower. DeepSeek 3.2 needs longer reasoning chains to match Gemini's output quality. On the absolute hardest tasks, it still trails Gemini 3 Pro. They're not claiming total victory. They're showing that the gap is closable and how to close it. Remember that widening gap I mentioned at the start? DeepSeek 3.2 just reversed it with 3 systematic innovations: DSA, scaled reinforcement learning, and massive agentic task synthesis. Gold medals at IMO, IOI, ICPC World Finals, Codeforce's rating above 2700, beating GPT-5 on multiple benchmarks. This is the blueprint for competing with billion-dollar labs. If this trend continues, the gap between open source and closed source models might not just close, it might disappear entirely. And again, if you're a business leader who's trying to figure out what this means for your AI strategy or how to implement these models, that's what I help with. The email's in the description. If this was helpful, hit that like button and subscribe for more breakdowns like this. Thanks for watching. See you in the next one.